Hi, everybody. We're going to make a start. Thanks, everyone, for coming. We got a smaller form today. Guess everybody's on holidays. But again, thank you so much for coming. So we're actually running the last Connectivity Cafe for this year. And we're lucky to have Udi with us. He's one of our in-residence founders and founders in residence. And he's going to talk to us about drip irrigation and the solution that his company offers. And that's pretty much it. So I'll hand it over to you. Yes, sir.
Yeah.
Sure.
Hi, I'm Jackie. Sam just asked me to do the acknowledgement of country. She knows this is dear to my heart. So we acknowledge today the traditional custodians of the land on which we meet. Always a little bit of a contested space, the Gimoy, Wallabara, Yadinji and the broader Cairns region, specifically here the Irrigation and Jabbergai tribal groups. We pay our respects to their elders and to those amazing emerging young people who are coming through. And we continue to enjoy working with them and absorbing their knowledge and traditions.
Good morning, everyone. Thank you, Jackie. Thanks, Impact 10X, for inviting me to talk about NDRIP. And as Omer said, I'm one of the founders in residence here at Ideas Lab JCU. So thanks them. Thanks, JCU, for having us. So my name is Udi, for those of you who don't know me. And I'm the general manager for NDRIP Australia. And in the next 30 minutes, I'll try to explain about the concept of NDRIP. NDRIP is a gravity-powered drip irrigation, and the concept of NDRIP Connect, our decision support system. And I'll also try and explain a little bit about NDRIP's journey here in Australia. We've been here for 7 years. I think it's quite interesting, maybe for Impact 10X and for other companies to learn about us and maybe learn from our mistakes. Well, I'll talk to you all more about the collaborations that we have and here in Australia and outside of Australia in the world. NDRIP is a global company. But I want to start with this graph. So what you see in this graph is a share of the global land that is affected by drought. And what you can see here is a very clear trend. We can see that over the last 120 years, the trend has gone up. We can see that it's more than doubled. So direct impact for agriculture is that more land impacted by drought, meaning less land for us to grow our crops. This is a graph that I borrowed from the OECD. It's a report that they make for the global drought outlook. Shows us a very significant trend of water scarcity and droughts. But I thought I'll take it and I'll show you a graph that is more closer to home and closer to us, to NDRIP. NDRIP has been working in Cecil Plains. It's a small town on the Darling Downs, and it's about 2 hours west of Brisbane. And we worked there since 2018. In 2019, when we worked there, the farmers told me this has been the worst summer we've ever had. So I went back and actually checked the weather stations. You can go back to BOM, the BOM weather stations. You can check back. Sometimes you can get 130 years. This graph is only for, since the 1980s. And where circled in red is when the weather station wasn't working for those years. So, but the trend is very clear. It's actually quite scary. When they said 2019 was a tough summer, it was actually the driest summer in 130 years. So the rainfall that year was 156.9 millimeters. And when you look back 130 years, you'd see that the driest summer we've ever had, other than that, was in 1915. It was 306. So about half of the lowest that we've ever had was in 2019. So they're quite right about that. But when you look at something that, in my view, and other climate researchers that find it a little bit more dangerous, is the volatility. When you look at what happened after 2019, the next 5 years have been the wettest years in Australian history, the consecutive years. In Sessile Plains, there was 1 year that it dropped a little bit, but overall, if you look at 2021 was the second wettest, and then 2024 came and dropped it into the third wettest. And so you can see volatility of very, very dry to very, very wet. But if we're not looking just on climate, and that's not scary enough for us, let's look at population, which is another very strong factor impacting water scarcity. It took us humans over 300,000 years to reach a total population on this planet of 2 billion people. So 350,000 years, slowly building up to 2 billion. And that happened in 1927, less than a century since, and we're now over 8 billion. In 100 years, we're now over 8 billion people. So if you're not scared, I don't know, to me, that's a bit scary. Like if you see that trend, and the scariest thing is that water is a finite resource. We're not making more water. More people, but more people, more food, more people need more animals need more food for them to eat, more people need more clothes, more industry, there's more consumption. So we need to be a lot more clever in how we actually utilize the water. And when we look deeper in how water is utilized, we see that, 70% goes to agriculture. 70% of the world water goes to agriculture. And let's look deeper to that, and we'll see how is the ag consumes it, and we'll see that 85% of it is irrigated by the most ancient way of irrigation on the planet. 85% are flood irrigating. For those of you, I know that online there's a few farmers, and they'll be more familiar with irrigation systems. It's a system very simple that you're pushing water from the highest point to the lowest point. So from the river or from channels, you create a little slope in your field, and you just pushing the water from top to bottom. Not the most efficient. I have to say, here in Australia, we must be the most efficient, and the most sophisticated flood irrigated farmers that I've ever seen. But still, it's not the best sufficient. So, recap till now. I hope you agree with me, whether it's for climate change or for population, that there is water scarcity. 70% of the water goes to agriculture. So this is the focus of how we can save water and use it more efficiently. Thirdly, 85% of water that goes to ag is not used in the most efficient way. Now, there is one thing that was invented about 60 years ago, and it's called drip irrigation. Conventional drip irrigation. We call it convention because we created something new. All right, that's our claim to fame. NDrip is a gravity-powered drip irrigation, but only 4% of the world irrigators are using conventional drip, and it's because it's quite expensive. And hopefully, I managed to connect all the dots for you to understand where we're coming into this picture. So this is NDrip, and this is what we offer. Two systems. The one that you see on the left in the green, this is the simple gravity-powered drip irrigation. We connect to a water source. It could be a dam, it could be a channel, it could be a bore. We transfer the water from the water source into a little tank, which I'll show you in a minute. We'll see the visual will be a little bit easier to connect to it. But we're pushing the water into a little tank, 90 centimeters in height, 800 liters in volume. And from there, you can see that blue line that goes sideways, that's a submain. And then you'll see laterals or drip tape connected to that submain, and we're irrigating. If you've seen drip irrigation before, that you see that from that tank onwards, it looks like any other drip irrigation. The key here is that we're only using 1 psi, actually less, 0.87 psi to irrigate. Conventional drip irrigation requires 15 to 20. What it means is that we now created a drip irrigation solution that is more affordable. Okay, affordability is the key. Drip irrigation that you see right now is used in high profit vegetables, fruits and vegetables, but you won't see it irrigating cotton and maize and sorghum and wheat, right? That's the big stuff. Like broadacre is what's mostly grown, rice and all the other those other crops. And we're allowing broadacre farmers now to irrigate more efficiently. And the system that you see on the right, NDRIP Connect, is a decision support system. Like I said, we collect information from a few sources. I'll show you later in more detail, but generally speaking, it's a web app taking information and providing the farmers irrigation recommendations and plant health monitoring, right? And when you combine those two systems together, you can allow the farmers a more efficient way to handle the most important resources that they have on the farm: land, water, and labor. And those two systems can work together, which we always prefer, but we can work independently. You can put NDRIP Connect as the decision support system on conventional drip. You can put it on center pivots and even on flood irrigation. This is just some visuals so you can see how it is in real life. We don't do small. You know, we have projects of 30, 50, 100 hectares. That's the size that we work. You can see the main lines on the right-hand side, the blue and the black. So a main line runs across the field, and then it's feeding into individual blocks or individual tanks, and every tank is responsible for a block. A block could be 2 hectares, but it could be 15 hectares. That doesn't really matter. And you can see that from the tanks, there's what I showed you earlier in the model, there's that other blue line, which is closer to the plant. That's our submain, and all the laterals are connecting to it. And from there on, we're just irrigating. And what determines the pressure is the tank. The height of, or the head that we will create in the tank will determine how much pressure, whether it's 40 centimeters or 80 centimeters, whether it's 0.8 psi or 1 psi, that's what is determined there. Even though you can see the black lines above ground, they're actually underground. The only first couple of meters will be above ground, and then it goes under. This way, we're protecting it from the elements, wind, change of temperature between day and night, etc. You can also see on the right-hand side, you see in the tank on the rim, you can see that the lid is on the side, and on the rim there's a white bit. That's a net. That's our filter. One of the things that makes NDRIP more efficient and more affordable is that we do not require pumps and filters. Filters that you see that need to clean water for other systems, they require a lot of energy. So our net takes the water that comes from the water source. If I'm taking water from a dam, I can take fish and yabbies and debris, whatever comes in. So we don't want this going into the system. That will be collected in the little net, which depends on how dirty the water source is, will need to be cleaned from time to time. What you see here on the left-hand side, that's actually a beautiful picture where you can see the little circles. So as I said, this is just maybe before planting or just after planting when you can't see the seeds, obviously, but you can see the drip line is underground. And when it starts irrigating, creating those beautiful circles, water goes directly to where it needs to go. We're not wasting anything. It's all in a closed system. Now, without going into too much details, but I think it's important to understand. It's important to understand roughly what is the difference between conventional drip irrigation and NDRIP. And Ramona here, my amazing office manager, will show you a little bit, if she can pass it on. But conventional drip irrigation, most of it, there's all sorts of, there's a variety of drippers, but most of them are just working like a zigzag or some sort of a labyrinth. So you're pushing water from one end, you see where it says water inlet, pushing the water, then it goes into that zigzag and goes out from the other side. It means that we have one pathway for the water to get through. If I'm irrigating a plant which is 300 meters away from me and needs to go through that little tiny hole, it needs to get in with high pressure, okay? Another disadvantage of this structure, the conventional drip irrigation, is that when you have one pathway for the water to go through, any grain of sand or silt can block it. That's why they require the high filtration, which is quite expensive. And this is where the innovation comes into place. And I'll show you here, and you can look over there. The dripper that this is obviously just a model. You can see with Amona the tiny little dripper that goes into the tape. Our dripper is not a labyrinth, it's a tube. It's an empty tube that we created a rod that sits all the way right into the one, and it's welded on one side. So what you have instead of the zigzag, which means that one pathway for the water to go through, we now have multiple pathways in the space that is created between the rod and the tube, right? So naturally, once this tape, for a sec, when this tape is full of water, this is your dripper. When the drip tape is full of water, water will just fill in this space naturally and will go in naturally. And if there's a bit of dirt or even bacteria or anything else that is blocking it here, it's not blocking the whole entry or the inlet. And with some treatment, and we use chemicals and we use extra pressure if we have to, then it cleans it. So that's just to give you an idea and understanding why it's different and what's different from the conventional. Important to mention that NDRIP is a one-stop shop. So we take everything. It took us a long time to understand that we have to do everything, because when you're going into a market that flood irrigates, it means that you need to start doing market education. That takes a long time, and that means that we need to do everything on our own for now. We take it for the full process from survey. So survey is a very important factor for us. If the farmer, some farmers will already have a survey. The survey basically tells us what's the elevation of the block in every square meter, or if you want every 2 centimeters of the block. And from that, we take that survey, which if you think about it, the elevation is basically just a pressure map. When you know the elevation, you know how much pressure is applied to every dripper and how much water basically as a result will be going out of the dripper. So that pressure map is translated into a flow map. And this way our design, we developed a software that will tell us exactly how much water will come out from every dripper anywhere on the block, where it's 2 hectares or 200 hectares. We actually do the installation. I'll show you in a second the system or the machine that we have to lay the tape in the ground. We do the maintenance with our team, always with someone from the farm itself, so that someone that we teach to do the daily operation. So we do not irrigate for the farmer. We tell them what to do and give them the instructions. But we also have the support. NDRIP Connect monitors the system. It tells me if I'm doing something wrong, if something is blocked, if there's a leak. And we take it all the way to the end. Once the drip tape reaches the end of its life, we retrieve it. We have our own retrieving machine. So we go into the field, roll it, put it aside, and take it to be recycled. So a full cycle from survey design to up to the right. Okay, this is how a design looks like. We don't have to get into too much detail, not to bore you too much, but that's a design of 60 hectares roughly, where every block is about 10 hectares. The circled one just shows you a zoom in on what you're going to get as a farmer when you get from the design. It will tell us what size are the main lines, the sub mains, how many hectares are for every tank. But one of the most important things for a farmer is what's the irrigation rate. So when I'm turning on the system, how much water is actually applied? And a farmer wants to know because he works with what the plant takes and what's the environment doing, temperature and wind, humidity, etc. In this specific case, you see 1.17 an hour. I've turned it to 10 hours, nearly 12 mil. That's what they want to know. A short video to show you how we lay the tape in the ground. This is a machine that we developed together with, doesn't want to stop, doesn't matter, but it's a machine that we developed together with a company from the US called Andros. They have all sorts of farming machines, but they specialize in drip irrigation machinery. In this specific case, we had every 3 meters that we put a tape. And as you can see, or like you saw earlier, the drip tape is laid 5 centimeters, 2 inches underground. That's how it's protected. Right. So I'll get to questions a bit later, but at this point, I hope that I managed to explain how the system operates, how it looks, and why NDRIP is different from conventional drip irrigation. In the next few slides, I'll try to get you to understand in the last 7 years, due to many things, we had to make some very important decisions to keep ourselves relevant to the market. So we started here in 2018, which was in the middle of one of the toughest droughts Australia's had from 2016 till 2019. It was a very tough drought. I think the toughest in the last 40 years. And then from then on, as I said, we went to the 5 wettest seasons. But before we got to that, Australia is a very, very big country, as we all know, and we had to focus. Where do you go? You can't just go anywhere. Someone calls you from South Australia, or someone calls you from Western Australia or New South Wales. Where do you go? So we had to choose, and we chose to focus on a crop, and cotton was the one that we chose as the most suitable one. Why cotton? For several reasons. First of all, remember, NDRIP is a gravity-powered drip irrigation. 90% of cotton is irrigated with flood. So it means that if I'm thinking the suitability of the block for us, they're already suitable for us, because any gravity-powered flood irrigation is suitable for NDRIP. All I do is put the drip tape in, and the block is already suitable for us. So 90% is already flood irrigated, suitable from gravity point of view. Second, all of them operate with GPS tractors. If you have drip tape in the ground, you don't want that the tractors will step on it, especially if you're working with 1 PSI. If a 36-ton tractor drives over it, it compacts it, it can push it underground. If it's wet, it's even worse, can push it 20, 30 centimeters underground, then try to reopen it. But when you're operating with a GPS tractor, always A-B lines, always in the same spot, whether you're planting or whether you're weeding or whether you are harvesting or picking, it's always done in the same lines. That's great for us. Also, cotton is quite a thirsty crop. It requires between 10 to 12 megaliters per hectare. And obviously, depending on the season, how much rainfall we've had, during the drought, they actually had to irrigate 12 megaliters. So if you don't have enough to finish the season, you're not even starting. 2018, I think, the cotton industry on a good year will plant 600,000 hectares. 2018 was about 60,000. That's how bad it is when you don't have water, you're not even planting, because it's not worthwhile. And the last reason we chose cotton is that when you look at the broadacre crops, it's quite one of the crops that is more profitable. If you compare it to sugarcane, or if you compare it to maize or others, in most cases, in most of the years, it will win. It will have more profit, which means that the farmer can afford maybe more than other farmers to actually use the system. So that was the crop. The second important decision that we've made, we had to focus on a region. Where do you go? They're growing cotton all the way on the Murray-Darling Basin, thousands of kilometers, and also, in Queensland, even if you go up here 4 or 5 hours north, they're growing cotton. So we decided to focus on the Darling Downs. We put our base in Toowoomba. Toowoomba is about 2 hours west of Brisbane, and working around Toowoomba, 3 or 4 hours from Toowoomba onwards. And then we chose another area, northwest New South Wales, which is Moree, Narrabri, Boggabri, Weewar, for those of you who know the area. That's it. That was because we just couldn't. We could not. Otherwise, you'll need to have tens of people and you need to send them everywhere, or you have to have bases for technicians everywhere. So that's why those were the important two most important decisions. But the next decision we took about 2 years ago, and it started 3 years ago when, by chance, a farmer approached us and said, "Look, I have a bit of water. I don't have a lot of water, but and I'm predominantly a dryland farmer. Dryland farmers, for those of you who don't know, just rely on rain. They don't irrigate. If you have good rain, you'll get good yield. If you didn't have rain, you may not have anything." And we worked with them, and we tripled the yield. And like, hold on, we might be onto something here, because if a farmer who came out of the drought and now he has a lot of water. Some of the places, in 2019, I went to a place, he said, "I got 3% allocation." And you go there in 2024, and he says to me, 300%. So you can accumulate water, basically. So if you don't have incentive to save water, then how am I going to sell a system that needs to save water? That, the main objective is to save water. So we decided of increasing productivity. All right, so that was the main shift, and we were driven into it because of the weather patterns. So in the next few slides, and I won't go into too much details, but I thought I'll show you just a few examples to give you an understanding the type of productivity that we're increasing. This is a farmer that had two little, there's two yellow dots that you see on the left-hand side. Those are two bores, very low flowing bores, which means that you can't really do anything with it. He tried flooding the red rectangle that you see there is about 25 hectares. He tried to irrigate that with flood. Took him 2 weeks to irrigate 25 hectares. If the flow is too low, you're just unable to do it. And no one's going to invest too much in other systems because they're just too expensive for such a small area. With NDRIP, we took that because NDRIP requires really low flow and low pressure. We took that, and with 2.5 megaliters per hectare only, we tripled the yield to 7.5 bales to the hectare. Right? It doesn't sound much, because if you're looking at cotton growers who are fully irrigated, they can reach 15 and 16 bales to the hectare. But if you're tripling your yield with a very, very small investment, that actually changes the equation. So he went and got an approval for another bore, and then we've added another 66 hectares, and that's how we're going into a farm. We see, let's see how we can help you utilize your water better, utilize your land better, and get higher yields. This case is different. This farmer has a lot of water. He's not short of water, but that specific block that you see there is affected by a river that from time to time will just flood. And when the river floods, it pushes the land. The natural slope that they have goes from east to west, all right? But when you're pushing water with the river, it changes, and it changes your slopes, and it pushes pebbles in and other things. Also, when you're flood irrigating with siphons, for example, it's a lot easier if you have a square block or rectangle block. When it has different shapes, and think with me why. If you have a long row and you're running it, how do you run it? You turn the channel on and you put the siphons in, and the siphons are running. A short row of, say, 50 meters, after about 6 hours or 4 hours, you're done. The water starts going into the drain. But if you have a row that is 600 meters, you keep going, and you keep going. So what you have is the short runs keep irrigating and wasting water while the others don't, right? So odd-shaped blocks, change of soils, so it's basically, he decided that he never irrigates this block. He will choose to use his water where it's more efficient. right? Why waste water on a block that is difficult? So he was budgeting on 2.2 for dryland cotton. We reached 11.3. That's all. That's 5 times more the yield, becoming quite interesting. I'll skip that example. Very similar, but also converting dryland blocks into irrigated. What you can see here, he got 2.5. It doesn't show here. The yield is actually 2.5, and the irrigation is 3.5 megaliters. So nearly 4 times more yield in this case. This is another case study. We're actually renewing this block for the 3rd time. They're using water that comes from a dam. The dam is not always full. If there's high rain, the dam will be filled with water. If not, it could be empty. The blue block that you see here is part of a bigger block that 25 or 30 years ago was designed for flood irrigation, but deteriorated. So the slopes are bad, all the channels are broken. The farmer had the decision to make. I'm either converting it back into flood irrigation, or I'm doing something different. He chose to work with us, and again, look at this. The results were quite amazing. Reached the newspapers as well. We tripled the yield with very little water, with only 3.3 megaliters to the hectare. He went on after the summer season with cotton. He got into barley. The dryland barley got nothing because there was not enough rain that season. We got 3.2 bales to the tons to the hectare. Right. So this was just to show you the journey and how NDRIP basically converted. Now, when people know us here in the market, in the cotton market in Australia, they know that NDRIP is fantastic for supplementary irrigation or for converting dryland. But now I want to show you NDRIP Connect. So we collect information from few sources. The first most important resource is the farmer. The farmer knows his land better. He knows also the history of the block. The history of the block is important because depends on what plant he had before this season, means how much nutrients he had in the ground and how dry the soil is. You know, if you had cotton the following season, the soil is empty. And it's taken all the moisture and it's taken all the nutrients. We also normally, a farmer before he starts the season or she starts the season, they do a soil test. The soil test will tell us, you know, what you're facing, what's your foundation, what's the baseline. We have a weather station that will give us temperature, evapotranspiration, wind, rainfall. We have our system or any other system that will report to us how much we're irrigating. There's a water meter that the water meter will tell me how much I'm actually putting on. And the MVP that we use, and that's another innovation by NDRIP, is a soil moisture sensor. And it's based on a tensiometer, the same idea of a tensiometer, but what's more unique about this tensiometer is that it does not need any calibration. And a tensiometer, you poke in the ground and you will only know the 1 centimeter where you poked it. So if you have a 100 hectare block, where are you going to put it? How many times will you poke it to know? And soil's different. If I test this soil and I'll go 100 meters that way, the soil will be different. So what we've created is a geotextile, which is a big word for a piece of cloth that is permeable. We impregnate it with fertilizers, and then we allow or encourage the roots to grow on it. And then you can see in the next picture, after a few weeks, the plants are actually growing on the piece of cloth. And we're not just representing soil, we're also representing what's happening with the actual plant and what it needs and how much it requires. So basically it's showing you stress levels. The cloth is about 1 meter long. So we're not just 1 centimeter. We will apply a few of them in different parts of the field so you get a much better representation of what's going on in the field. And say in cotton, for example, if you have 1 meter, you should have between 12 to 15 plants growing on it. So that's another resource that is used for NDRIP. And as I said, it's a platform, it's a web app that this is what you see when you turn it on. It could be on your phone, it could be on your laptop. You see the traffic light on the top. That will tell you, based on the soil moisture probe, whether we're in the green or the red. The farmer can see that immediately, say, okay, I'm all right, I'm good, or I need to irrigate. On the left-hand side is all the blocks that they have. They can choose from the farm of which block they're focusing on. The one that you see that is highlighted is the one that you'll see with the graph. The graph is related to a satellite image. You can see on the satellite image, there's a few dots. Each one has a different color. That represents a different probe. And then that is correlated in the graph to how each probe is performing. And you can see that when it stresses, it goes down. And when there's a blue line over there on December 16th, it was irrigated. And you can see that it goes into saturation and it goes into stressing mode again until it's irrigated again. This, you can choose 1 day, 1 week, 2 weeks, 1 month, 6 months. So you can look at patterns and you create your own patterns. When you put your cursor on the blue line, you can see for how many hours you've irrigated and how much water you applied. And if it's other blue, it will show you rainfall. We also show satellite images that will show us NDVI, which is basically we're monitoring how the plant is doing. And the bluer it is, the better the block is doing, the better the plant is doing. If we have red spots or yellow spots, it could be because, say, if you look at the right-hand side, they're probably planted later. This is more advanced. This could be different crop as well. But if we put it together, we can look at it and see maybe there's an issue with the irrigation, maybe there's an issue with the soil, or a disease even. And when you go online, you can check and choose the satellite image from 2 days ago, from a week ago, and even a few months ago, and you can see the patterns of how the plant is doing. NDRIP is a global company. If you know a little bit about irrigation or you're from the industry, you'll not be surprised to know that it was established and innovated in Israel. That this is where our head office is, but we operate worldwide. The important markets for us are the US, Australia, and Asia. In Asia, we operate in Taiwan and India at the moment, but growing to other places as well. And I want to show you the companies we are partnering with, we're collaborating with. First one, PepsiCo, invested in NDRIP about 4 years ago. Pepsi, the Pepsi drink as you know it, also has a lot of investment into cropping because it has corn snacks and potato snacks and everything else, but they're not growing it on their own. They have farmers all over the world that will provide them with the crops, and they will make that into snacks. But just like we saw earlier, the water scarcity and the increasing land that is affected by drought, PepsiCo saw that there's a threat to their supply chain, and as an attempt to protect their supply chain, they collaborated with us, invested in NDRIP, and now they're encouraging their farmers to use in more advanced, more innovative solutions. They can improve the water use efficiency and grow better. RiceTech is another company. It's owned by a big fund called LG Group, and LG Group owns RiceTech, which is the third largest rice seed producers. And rice, not only that uses a lot of water, but also has pollutes with methane. And we work very closely with them to improve how we are irrigating rice. Google actually should have added Meta as well, is another one, which is quite interesting. I'll get to that in a second. That's a little interesting surprise. Here in Australia, we collaborate with the elders. This just started about 2 months ago, and I'm glad to say, obviously, elders is nationwide. They have hundreds of branches all over Australia, and we work together. We work with their agronomists, and they're promoting us with working together. But a twist in the plot is the next slide. NDRIP started working with data centers, Google, Meta, Amazon, and others. This is something that no one could have thought of. We definitely did not predict that. But companies like Google, when they're operating a data center, the data center has servers, and those servers use a lot of energy, and that energy is getting really, really hot. And if you want to cool it off, in most cases, you do it with water. So Google does not use NDRIP to cool off the server. So we don't put our drip tape on the servers and cool it off, but we're working together in a way that we can actually offset, or you can call it water replenishment. You can call it water credits if you want, but it's Google and Meta's responsibility to the environment, to where they're working. So the water that they're taking and the energy that they're taking, they give back to the where they're working. So, for example, in Nebraska, the aquifer where they withdraw the water from, they came to us and say, we're using, say, 2,000 megaliters every year. How many hectares of NDRIP will you need to install to offset the 2,000 megaliters that I'm using, right? So instead of them reducing it, they cannot reduce, but they can assist the farmers in the same aquifer to reduce how much they're using. That basically we're offsetting it. And what you see in this graph is the data center and the farmer has nothing to do with each other. The data center comes to us and says, this is, so we signed with them in Nebraska and also with Meta in Nebraska. We signed in Texas, now in Taiwan. Because data centers are the fastest growing sector in the world. Also here in Australia, by the way. Less here in Queensland. I think that Victoria, New South Wales is a bit faster, but they come to us, we sign with them. And then we go separately and talk to the farmers in the region where they are withdrawing the water from, and then we work with them. All right, does that make sense? And then the farmer, if she just saved 2 megaliters every hectare, it's not given back to Google, or there's no connection between them two. It's reported, it's obviously validated. So NDRIP we have our systems, but we have a third party that validates that we're actually saving the water, and that goes as water credits to Google. All right, so it's a win-win situation to everyone. The data centers are giving back to the environment. NDRIP is selling their systems, and the farmers are more efficient, growing more with less. And yeah, I think I'll leave you with that, and I'll leave you for questions.
Anyone has any questions? We've got a few. And for the people online, if you want to ask a question, just put it in the chat, and I'll also ask Udi.
Thank you for the excellent presentation. Does the NDRIP system have any implications for salinity?
For salinity?
Yes. Is it better or worse than other systems for salt in the soil?
It is better. And you can also use the system. So NDRIP, I didn't mention it, but the drip tape, you can apply chemicals and you can apply fertilizers through the tape. Sometimes you can apply other chemicals to balance the salinity in the soil. But in many cases, what creates more salinity is when you're flooding, right? So when you're applying smaller amounts of water, we will not improve. If the soil is already with the high levels of salinity, we will not improve it, but there's less chances of us changing it to worse, if you know what I mean.
Thank you. And one other question you may not want to answer. If you were given management of Cobby Station, what would you do?
I would love to be the manager of Cobby Station. Cobby Station, for those of you who don't know, they have about 30,000 hectares of irrigated cotton, and I would convert it all into NDRIP. At least I'll suggest.
Thank you, Rudy. That was great. You said in 2018 about choosing Toowoomba and then the Darling Downs for your locations. Can you just touch on why you ended up in Cairns?
That's a different story. It got nothing to do with NDRIP. I have been here for 13 years. This is my base. This is my family, my community. And we realized early on that it doesn't really matter. It could have been probably easier for me if I lived in Toowoomba or lived in Brisbane, but because Australia is so big, you have to do a lot of commuting regardless. So whether I'm flying from here to Sydney or from getting from here to Narrabri, it's still quite a long distance. Yeah, but no worries.
Thanks, Udi. Great presentation. And we're really proud of having NDRIP in our JCU Founders and Residents portfolio. And also the fact too that you give back to the portfolio and JCU, your contributions back with research, helping out in our community garden, for example. There's a lot of things that Udi does that nobody probably knows. I just wanted to acknowledge and also thank Udi and also Ramona for what you give back to the portfolio and also to JCU. I'm also wondering whether or not, because obviously there's going to be a real big growth of data centers in Australia. We've got so much land. US is probably, going to be looking over here with our connectivity, our ability to move fast and build and the infrastructure.
Mm-hmm.
And I'm wondering how you're preparing for that future growth and where you play in that space. I think you've got some great use cases with Google, with Meta, etc. And the other question to that is, are you chatting with NextDC, which are the data centers here in Australia?
Okay, I'll start with the first question. So you're right. Data centers are growing, and we're trying to work with them. So the way it works, it's a bit complicated with Google is a beast. It's a beast. And there's a department that operates on sustainability and data centers, and they decide where they want to work. And also the way they work is they have to have a direct relation with where the data center is located to where the water is withdrawn. Here in Australia, most of the data centers will be along the coast. So if you look at Sydney and Melbourne, it will be not far from there. And where NDRIP operates now, it's more further inland. However, we just signed up with Google another contract where the way we are reducing the water is just by using NDRIP Connect. Reminding you, NDRIP Connect is the decision support system. So I'm not installing any irrigation system to reduce the water. I can place NDRIP Connect anywhere in Australia and then report the water savings this way. We're trying to convince them to do it this way. And another thing that we're trying to do, whether it's data centers or other growth areas, we're working here on Northern Australia needs a lot of development. And there's, as you know, you've been part of it as well, there's conferences and there's a lot of work to develop Northern Territory. It's undeveloped, basically. And we're working together with JCU, and hopefully I'll have good news early next year to tell you that we're working together in the Northern Territory, trying to improve water use efficiency there, working together with the Northern Territory government and Northern Territory farmers, anti-farmers. What was the other question, sorry, about the data centers?
I think you've answered that. It was, have you had discussions with the next
Oh,
DC?
Is
Yeah,
Next DC the forum that includes all the data centers?
correct.
Yes. So I've
Yeah.
spoken to someone from the Victorian government
Yep.
who is in contact with the forums,
Mm.
and they invited me next year to do a presentation.
I just want to make sure you got the intro
Yep.
because Craig Scroggie is in our ecosystem for the AI hub.
Okay.
So I just want to make sure you got that
I'll have
connection.
a chat with them. Great.
Fantastic. Any other questions?
There's no questions online. But yeah, that's it. Thanks everybody for coming for the last Connectivity Cafe. And then just so you know, we are looking for presenters for next year. So if you have anyone in mind or you have a topic that you want to speak out, come speak to me or Sam or Santi. We do have several candidates so far, but if you do have a topic that you think would be valuable to the community, just let us know, please. And other than that, enjoy your holidays. 1 second. Yes.
Just to that point, thank you for bringing that up. What we want to also hear from you is what format worked well for you. You know, we've played around with a couple of different formats. We've had workshop style formats. We've had great presenters, our founders and residents portfolio. We've also had a lot of our research presented. So bringing in the interns that I work with throughout the year, some of our PhD candidates via Kranthi. So we'd like to hear from you more about what other avenues or maybe introductions that you would like to see for Connectivity Cafe 2026. Gosh, that's just round the corner. But I thank you very much for participating, for giving back to the community. And Lucy will be perhaps coming over to your lovely co-working space in Cairns and maybe have a connectivity cafe there so that we can see what the co-working space looks like. So, but yeah, I'd love to hear your ideas around our series for next year. And as you know, Connectivity Cafe Plus is what Udi offered today. So we have a real specialized, and it goes out with a lot of marketing. The in-between is where I can bring in who I know in the ecosystem and those that volunteer to give back. So did everyone like that format of like a Connectivity Cafe Plus at the end, which is our partnership with Mind Designs and the Regional Enablers program? Yeah. Anyway, we'd love to hear your thoughts. And we also have some Christmas treats. So please help yourself to some Christmas treats on the table. Sorry for those online that can't join in, but wish everyone a really happy and festive season. If you're traveling, travel safe and be well, and look forward to seeing you in 2026. Thanks, everybody.
Thank you. Thanks, everyone.
Thank you, Udi.